Welcome to Chapter 7, Growth Models and Finance. I'll give you a brief introduction here on what we're going to cover in this last chapter in the course. So, first we're going to cover growth models. And what we mean by that, let me give you an example. Here's one of the questions from Part 1, which is the growth models section of the homework. Here's question number 7. Diseases tend to spread according to the exponential growth model. You've probably heard that. I'm making this video during the COVID days, and there's a lot of talk about the exponential growth of COVID. And diseases tend to grow that way because, as we now know quite well, people spread them to people. So a few people spread to more people, etc. It's explosive growth. And here's AIDS, for example. In the early days of AIDS, the growth factor was about 2.1. In 1983, about 1,700 people in the U.S. died of AIDS. If the trend continues, how many would have died of AIDS in 2007? Well, it turns out it would be hundreds of thousands. It would grow explosively. So this is the first video, question number 1. What are we going to study in growth models? Which kind of model are we going to study that's going to be of very great interest to you? Exponential growth. You'll learn how to deal with the formulas for exponential growth, to take something like the COVID crisis and use the math, understand better the math they're using to figure out if it's growing exponential at a certain rate, how much is it going to be in a year? And we'll answer lots of questions about that. Exponential growth. Not everything grows exponentially. There's other kinds of growth, but exponential growth is very common in our society. And so you'll learn the formulas and learn how to use your calculator to predict and understand exponential growth. So that's the first concept we're going to study. I won't go into any more details. I'll let the homework teach you that. And then one other topic in Chapter 7 is finance. So let me come down here. Here's a finance question. Now this is part 2. And it's the finance part. So part 1 is the growth models, exponential growth being the key. Part 2 is about finance. And so we have a question here. Let's, in fact, which question do I want to, let me back up. Let me do this question. This would actually be the best one right here. Part 2 in finance. This is actually question number 6. Let's suppose you deposit $400 each month into an account. Let me change this to 7% because that's more typically what you can earn, or even 8 or 9. If you invest in, if you go with an investment firm, you can pretty safely get 7-8% average compound interest. So it's not hard to do that. If you go with a typical investment firm, they'll make you 7%. So let's suppose you put $400 in for savings for retirement each month. So that's a car payment, right? So let's suppose you decide, hey, my retirement is worth a car. So I'm going to make a car payment to my retirement account. I'm going to go with some company that does mutual funds, and that'll invest my money, some big company that's got a good proven track record, and they'll guarantee at least 7%, usually 8 or 9% regularly gain on your money. How much are you going to have in 30 years when you're ready to retire? Well, let me give you the answer. It's going to be $488,000 about, just roughly. Almost $500,000, notice. That's a lot of money. Just by putting a car payment away every month for 30 years and having it grow at 7%, which is actually low. You can probably get 8 or 9 for most mutual fund investment. Over the last 50 years, mutual funds have averaged, I think it's over 8% consistently. Of course, there's highs and lows, but the average over the last 50 or so years for mutual funds has been 8 or 9%. So this is not unreasonable at all. If you put a car payment away every month for your retirement for the next 30 years in mutual funds, you can make $500,000. That's surprising. Now, how much was the money you actually put in? Well, it turns out you only put in $144,000. And it turned into $500,000. How did it do that? The rest was interest. How much interest did you gain? You actually would gain about $344,000 in interest, meaning that's money they gave you for nothing. That's interest you gained. This is how much you put in of your own money. You put in just under $150,000 over those 30 years of your own money. That $400 every month. But you gained in interest 3 times that, almost. Well, 2.5 times that. Just under 2.5 times that. In interest, you gained almost $350,000 in interest. They paid you, bringing your total to $500,000. See how important saving for retirement is. See how easy it is to grow. So this is video question number 2. What are we seeing here? We're seeing the power of compound interest over time. So I want to show you the math so that you can be wise. This is the last thing I want to do for you in this class as you wrap up probably your math career here with this class and this last topic. So I want you to see how your money can grow over time. If you start investing when you're young and you put a good 30s, if you make 40 years out of this, these numbers go crazy. You can have a couple of million by just putting a car payment in the bank. Well, not the bank. Don't put it in the bank. Put it in a mutual fund every month. For 35 or 40 years, you'll have over $1 million. So that's the power of compound interest over time. That's question number 2. That's what I want you to see in this last topic of finance, the mathematics that will make you wise with the management of your money for your future. That'll be our last topic, learning about how math can be used and is used in current society. In this case, we're looking at growth, like exponential growth of diseases, and finance, the power of compound interest